I'm really happy today. Today we have our friend here, Naga, one of the teachers on Solana Turbine, a program that has been teaching loads of people how to dive and how to learn the Solana ecosystem. Naga was really, really helpful and accepted to be with us today, accepted to do a talk and a dive into Solana. We're going to be diving into some quick slides and then we're going to dive in code. Naga, brother, welcome.
Yeah, thanks, Alex. So my name is Nagaprasad, and you guys can call me Naga. I've been working on, building on Solana for the past 3 years. Just doing, deep diving into Solana programs, validator, you know, everything. I think everything about Solana. I'm working at ABK Labs right now. Contributing to some of the major open source projects on Solana, like Triton, uh, and Kodama, Yellowstone. So all these things are kind of the read layer on Solana. So I'm contributing to ABK Labs at the time. Also, I'm a teacher at Turbine. So Turbine is the uh, maybe we can call it as talent engine on Solana. So Turbine has a lot of bunch of cohorts running every quarters. There is a builders cohort, there is a Solana program development cohorts, and the advanced SVM cohorts concentrating on validator stuff, right? So, yep, I've been teaching at Turbine and also working at ABK. And I like to build developer tools, infra on Solana. Recently, I've been building some open source projects on Pinocchio. So, Pinocchio, if you guys have heard about it, so new kind of paradigm in Solana for writing programs slash contracts.
Wow.
Very compute unit efficient programs in Solana.
You
Right?
must be quite
Yep.
busy.
So
You must be quite busy with work. People are crazy for Solana these days.
yeah, they kind of I try to get myself involved in few projects, side projects. My if I find something interesting, I just want to build it, make some more as contributions, I guess.
And before diving into Solana, were you already working with Rust, or Solana was your first experience to Rust?
Yeah, I think Solana was my first stepping stone towards Rust. I was at a hacker house, a Solana hacker house. There's a that's an event, organized all over the world. So it happened in India as well. So I was attending that. I think there was a spark to learn Rust, get into Solana blockchain and stuff. I think that's where I started. Uh, yeah, I think after that, I've been doing a lot of Rust and Solana.
That's pretty cool, brother. That's pretty cool. Okay, let's go. I'm pleased to see your talk.
Yep, sure. Okay, so what we are doing today? So we'll be deep diving into Solana. We will not be covering the validator side of stuff, but we'll be deep diving into Solana programs, right? So in Ethereum, you guys have contracts, Solidity contracts. Similar to that, we have Solana programs. Solana programs, you can write these programs in Rust, Python, right? C or C++, even Golang. I think there is also support for TypeScript coming in, but all these are compiled down to a target called eBPF, where eBPF is the virtual machine that Solana uses to sandbox and execute the program logic, like instructions, right? So eBPF is called extended Berkeley packet filter. So that was developed earlier. It was simply a kind of VM used for, I think, for some networking stuff initially, but later Solana was looking to adopt this and put it into their runtime. So basically, the runtime consists of this virtual machine eBPF, where all your programs gets compiled down to eBPF, and when you deploy your contract to the chain, right? So that is what gets executed in the virtual machine. So in order to write contracts or programs, so I think I'll be going with programs, the naming convention, because in Solana we call it programs instead of contracts. So Solana programs mainly has this program entry point. I think we'll be looking at later. So that is the kind of an entry point, what we call, to your program. That is the function, the main function which picks up all your instruction data. We have in Solana program model, we have something called as accounts, which are this, which represent the state, and also you passing the program ID, which program you want to invoke. So these things come into play. Also, kind of explaining how the accounts model work on Solana is, so Solana doesn't incorporate states into program. Instead, it's isolated. So the accounts and program is isolated. So that is what allows us to do parallel execution, right? When compared to Ethereum, where Ethereum it incorporates the states into the program, so you kind of need to have this sequential execution because you are writing to the account, and again, you have to wait for that operation to be completed so you can update the states again. So that is what drives Solana and scales it exponentially. The parallel or the concurrent execution logic we have, because this is possible because you have to send accounts in a manner where you mark it as mutable, immutable, executable, through the instructions beforehand. So you know exactly what accounts are gonna be writable or what accounts are just readable, right? So you can have the account locks. So logs are in the sense is nothing but the mutex logs I'm talking about, right? So in programming, you guys know multi-threading and all. You guys needs to have some kind of uh, security for the data poisoning. So that is why we use these mutexes and all. So same thing comes here, and you kind of have this accounts model for that. That is what making possible to run programs parallelly and scale it exponentially on Solana. Yeah, I think we can jump into the three models of
Awesome.
Solana programming. So let's talk about Anchor. So Anchor is the, I would say, your starting point for Solana program development. I would say, it would be your C language, kind of how you started programming. I would say it would be a simple analogy to Solana where you start working on Anchor and you get started with that. So let's look at Anchor for some time. I have this repo here. Yeah.
Okay.
So I have this repository on Anchor. I would like to present to you guys. Yeah. So this is the repo I have, right? If you guys can see, this is how a Solana Anchor program looks. Here, this is written in Rust. We have some imports here, like some top level imports, like the clock, anchor lang. Basically, this is the single dependency that we need to write the contract. We have the switchboard v2. So switchboard is an oracle, price oracle, you
Okay.
can say. So this program is trying to kind of calculate the token prices. By knowing the token address, you can know the price from this oracle. So
Okay.
that is what this program is trying to do. So we have this declare ID macro here, and you have this address. So this is what you call a program address. It's a kind of identifier. You have it on chain, right? Because if you look at Solana's accounts model, it's a kind of we have a database called accounts DB. The database is a key. key value pair kind of design. So every account is indexed by an address, what we call as a pub key. It's a base 58 encoded. So here we have this program ID for this particular program, and that is the identifier, right? Moving on, the entry point for this is this program. So we have this program macro, which is a module,
Okay.
and inside that we have this instructions written as functions here. You guys can see we have around so one create price feed, and then we have append feed data, and we have calculate data spread. Yeah, so we have around 4 instructions that we can call, right? Okay, jumping onto this, we have this create price feed. So this represents a instruction that you can call from this particular program, and you also have a context for this. Okay, looking at the context, you can see that we have create price feed account. So let's jump into that. Okay, here. Okay, so create price feed is a context for this instruction, and you need to pass some accounts for this. You know, the states. You need the feed vector account. That is what the state I'm gonna use. Look at this. I think it's declared here. Yeah, so this is declared here. You guys can see it's marked with a macro called hash count. So this means in Anchor. So this is gonna be a state on Solana. So this is what gets stored on chain. What you mark it as a state, and you have some fields for that. You know, we have feed vector. It's a vector of float type, not tuples. And then you have a data spread. We have a float and authority, which is a pub key here. And you guys can pass the context here. Basically, the accounts that you need are sent through this. And here you try to get those accounts, and then we can initialize those accounts like this, right? So we can initialize the state. I'm initializing the authority as my context authority and the data spread to be 0. That is one instruction. So when I call this, this state will be created on chain. I have to transfer some amount of SOL, because I'm using the on-chain state space where I need to pay for the state.
Okay.
So this will cost me some lamports, depending on the size of the account I want to create.
Mm-hmm.
So then your account is gonna be initialized on chain. So if you want to look at that, we can head over to Solana Explorer. Here you can type, you know, any address you want to see, and that will just appear here. For example, I can say you want to look at USD token. I just typed USD coin. We'll go to that. So if you look at the USD coin, so this is again a state where it's a token, and as I said, it's a identifier is the address. We have some fields like current supply, the website, the mint authority, fees authority, decimals, all this stuff we have.
That's very
So
interesting.
we can also,
One, one,
yeah.
one question for you. You were talking about lamports. Can you please explain what is a lamport?
Oh yeah, yeah. Sorry. Yeah. So lamport is the denominations of Solana. So one Solana is equal to 10 power 9 lamports.
Oh, I
Uh,
understand.
yeah.
I understand. Awesome.
No, in Ethereum, it's like I think you have GWI
Yeah.
and yeah, WI, I guess. So these denominations, yeah,
Awesome.
yeah. So this is how an on-chain state would look, right? So this is a token that you have already published on chain, and you can see the data here of that account. Similar to that, we can have our own accounts. Uh, like it will be similar to this. Whatever we have, right, these fields will be there, and that could be existing on Solana. So you can create any kind of account you want. You just want to pay for the rent, and then you can have instructions to change the state. So how the state transitions is through instructions. So we call these instructions, and then you can make those changes. Okay, coming back to this append feed data. This is again another instruction, and we have a context for this read history buffer. So this is the context we have. I'm passing a history buffer. It's an account info. So account info is again a generic account. You don't know the type. You don't know the type of the account here. That is why you are saying it's just an account info. And account info is a generic type of account you have. And we are again passing our feedback account. So this is what we want to mutate or change the state of. So that is why we have the macro account mute. So mute in Rust, you guys know that it's a identifier to mark some variable or any object as a mutable, so you can write to that. Also, we have this another attribute called has one authority. So that means to say that this state, whatever we have here, it has an authority, and that should be equal to this one. And also, this is marked as a signer. So signers on Solana means that you need to have a signature for the transaction. So Solana has ED 25519 digital signature algorithm, and you can create key pairs and sign transactions. So that is how you authenticate wallets or authenticate any kind of entity. If you want to authenticate on Solana, you can use it, and that is how we use the signer.
Awesome.
So if I want to make changes to this state, so-called this state, then the authority needs to sign the transaction. So if you fail to do so, or if you're signing from a different wallet, even if the signature is there, so the verification, we have a verification for that, and the verification is gonna fail, and the transaction is never going to happen. This reverts, and it fails. Yeah. So yeah, that is what keeps Solana secure, and authenticated.
The authority.
Yeah. So yeah, private key, pub key, key pair.
Awesome.
Yeah, crypto. That is how Solana keeps its authentication. Looking at this, so you can see I'm getting the accounts. I'm getting also there's a clock on Solana that you can get the current time, right? And I'm looping, have a loop. So all this is Rust logic, what I'm writing here, and I'm trying to get Solana price here, right? And then I'm pushing it to my feed vector, and there's some few logic I'm implementing here. Also, we have these another instructions: calculate data spread. Again, this is some math, or this math logic.
That I have for
Yeah.
you is that on Ethereum we have ways of optimizing bytecode, of writing more efficient code. How that correlates to Solana? Can I do the same? So if I use a different type of vector or a more efficient type of string, let's say, will that make the program cheaper?
Yeah, obviously. So I would come to that. I'm just giving a surface level of entry point where people can get started. So Anchor is a good framework to get started and get to know Solana. But I wouldn't say Anchor is very performant and efficient in terms of use. So CU is nothing but compute units. So in Solana, we have these things called compute units. So every block and every transaction has this limit on the compute units.
Mm.
You cannot go beyond that, right? So for example, a transaction on Solana, I might be wrong, but it has around 4 million CUs, I guess.
Okay.
Not sure on the numbers, but there is some limit, right? So every transaction is limited to that CU level. So you cannot go beyond, and you can run an infinite loop, right? So you cannot run an infinite loop. You always need to break. Yeah. So for those things, you always need to meter the compute units. You cannot perform encryptions on Solana because of that restriction as well. I mean, encryption on chain, I'm talking about. Sure, you can do anything on the client side, but on chain, few things are uh, expensive. So need to keep track
Yeah.
of that.
Don't you have precompiles like you have on Ethereum, different precompiles for encryption and so on?
Mhm. I'm not sure about how that works on
Mm-hmm.
Ethereum, but on Solana, we have got a few things working, like for hashing and all. We have this KAK hashing and all. We have a different
Mm-hmm.
entry point that tries to minimize a lot of CUs.
Nice.
Also, a few things are coming up with encryption, I guess.
Nice. That's nice.
Uh, that would need a different entry point, optimized one, right?
Mm-hmm.
So yeah, I think it's there. We'll be able to achieve that, but not with Anchor. So yeah,
Oh, cool, cool. No problem. Let's go. Awesome.
yeah. So we'll be looking at a framework called Pinocchio next. That I will explain everything over there. How we can optimize programs, how we can avoid heap allocations, right? So here we have this whole state as a vector. You don't know this size of this, right? So if you don't know the size, then you should go with vector. But if you know the size of this, you can just use an array, fixed array, because that is a stack allocator and doesn't need heap and all, because heap allocations are again CUs expensive. So the goal is to reduce CUs on your program, because if you are able to reduce CUs, then it's more likely that your transaction is gonna be included in the block, right? So the scheduler on the validator always tries to uh, schedule transactions more likely that has less use. So that is the main goal we should have. So the optimization is gonna be the game, I guess. We'll go on that. So let's see the results. We just looked at the transact instructions and the logic. Yeah, let's see the results.
Awesome.
Okay, so this was the account, the state I have, and this is the vector. We saw the vector and the tuples, right? So this is the state. I try to call some few instructions and try to push to the state, tracking Sol price, at what timestamp, the price of Solana. Uh, at that time, it was around $36.
Wow.
Uh, yeah, yeah. So this is the
Good time to buy.
yeah, good time to buy that 365 day. Yeah. So this is the kind of 365 days data I have tracked on chain, right? You can see 26. I think this must be some maybe the standard deviation, I guess. Uh, you know, I would say we shouldn't do these kinds of programs. This is just for learning. I'm against doing this vectors and calculating all these prices on chain, because it doesn't make sense to do it efficiently. So I am just sharing this because we want to learn, get started. Yeah, that is the purpose of this. But when you want to move ahead and optimize, we kind of need to avoid all these things. You shouldn't go with writing programs like this
Mm,
when you want to optimize. Just to get started with, I guess.
interesting.
Yeah.
Why this is too
Okay.
heavy?
Yeah, because I mean, I think this was an assignment I got when I joined my first job. I think it was called Convergence, the company.
Mm,
They were working on derivatives, financial derivatives,
mm,
and stuff. So this was an assignment I got to write in Anchor. I think this was also my first Anchor program, my full-fledged Anchor program, I would call. Yeah, that is why I wanted to show it to you guys.
nice.
Uh, yeah. Okay. Uh, so testing. So yeah, Anchor also comes with tests. Very useful and very easy, right? So Anchor has got this thing called you can load the program using this. Just pass the ideal. So if you guys want to know about ideal, so ideal is called as interface descriptive language. So it is a kind of JSON file, right? Let me show you guys if that's possible. So ideal is called interface descriptive language. It's a kind of mapping that you need to generate clients. If you want to call an instruction using a TypeScript or a Rust client or a Python, any language you can use it. So if you want to call the instructions, then you need to know what things to be added here. For example, you have this create account instruction. You can see what are the accounts that need to be passed to these instructions. Also, you can see the name, the mutability, the signer. The signer says that if you want to pass it as a signer as true, then this account needs to sign the transaction, right? Because the runtime is gonna look for the signatures in the transaction if this is marked as true. So these flags are important. Look out for that because many times your people can make mistakes. And, even if the account is mutable, even if the account is signer, you may not sign the transaction and just send it like that. That
Interesting.
would fail and yeah, throw an error. So yeah, this is what an ideal does. It gives you the mappings. So what accounts you need, what data you need. So arguments are the instruction data that you need to pass. So here you can see the name and the type, and this is a defined type. If you scroll down, and you also have a discriminator. So every instruction on Solana is gonna have a discriminator because you want to discriminate between, let's say you have some 10 instructions, you need to discriminate which instruction you're calling, right? So that is why we need to have the discriminator. And here you can see all the instructions and the errors as well, and some metadata and the types. So create account instruction, it is a type, kind, struct, what are the fields, so everything is there.
Awesome.
So you can use this pretty much for generating clients. It's a single line of code. Just generate the client using the ideal. Very very easy to do.
Awesome, brother.
Okay, nice.
Awesome.
Can
We have it.
can see this, right?
Yeah.
Okay. Yep. Okay. Now I think we'll be diving into Pinocchio. So Pinocchio is a kind of library, Solana program library, which aims towards lowering CUs. If you guys want to know the repo, maybe I'll share it with Alex. He can put it in the recordings, I guess.
Awesome. Yeah, I'm gonna.
Yeah. So Pinocchio aims to lower CUs, make Solana programs more efficient and performant. It uses a bunch of optimization techniques, right? So one of them is disabling heap allocations. So why don't we want to use heap is because heap is a kind of space where you want to make allocations, allocate memory. There's a pointers involved. There's a growable size. There's resizing. All these operations are kind of CU compute unit heavy on the program side, but we don't want all these complicated stuff on our program. But there's also, flags. If you want to use heap anyway, you can do it. But if you just want to stick to, the stack, you can do it. So let me go to the entry point. So this is what a Pinocchio program entry point looks like. Uh, in the anchor, we saw a lot of macros. Here, we won't be doing that. Only wherever it's limited, we'll be using macros, right? You guys can see I'm using a Pinocchio
Yeah.
dependency.
Yeah.
Yeah. So also if we go to imports, you can see I don't need any other libraries, right? Everything I need is coming from Pinocchio.
Nice.
Also, I'm using these two, uh, few things utils. So we can call these as utils, like the log, pub key, right? And you need these two to invoke system program instructions and token program instructions, right? So in Ethereum, you have the ERC20 contract, which you want to call whenever you're creating tokens or minting tokens, etc. Similar to that, you have token program, system program on Solana, where you can invoke these programs. So similarly, a kind of, if you want to look at the analogy, so it will be like an API call, but here we call it a CPI call. It's called cross program invocation because you're calling a different program from from your own program, right? So yeah, these two things we needed for making CPIs, and you have got some dev dependencies here. The Solana SDK, Mollusk SVM. So Mollusk SVM will be using for testing. We also will be doing some benchmarking to test how many CUs have been spent on instructions, I guess. Okay,
Awesome.
so let's see the entry point. Okay, so this is where you declare your program entry point. You just pass the a function which takes these inputs exactly. You cannot have more fields or more arguments or less arguments. You just need to have these three: program ID, accounts, and then instruction data. Also, you have this no allocator. I'm using this because I don't want any heap allocations on my program. So I just use the stack. You guys want to use the heap, you guys can also opt default allocator, or I think you can do global allocator or something.
Okay.
Yeah, I think you can do default. Yeah, default allocator is the way. Using default allocator, it says this macro sets up a default global allocator that uses a bump allocator to alloc memory. So you can use heap using this, but I wouldn't recommend if you want to optimize programs. And just stick with the stack memory itself. And then here we do the so you guys can remember I said we need instruction discriminators. So here it comes to play. So we're gonna use the discriminator to map instructions here. As you guys can see, I have this instruction discriminate and data. But this discriminant is the first byte of instruction data you guys are passing to this. Then we're gonna map it to the corresponding instruction. Okay, let's look at initialize state. I'm calling this process initialize state. Okay, so what is the data I'm sending to this here? So initialize my state instruction data. We have the owner, the pub key. So pub key is a array of 32 bytes. Data, I just have it as array of 32 and a bump. So I'll talk about bump later when we are discussing about PDA.
Okay.
Let's look at this macros I have. So as I mentioned, so Pinocchio, we are trying to, save space, CUs and all. Why use representation C is because, so what makes C is that, so whenever you declare a structure in Rust, so Rust compiler will automatically change the order of these fields stored on memory. So it's trying to, reorder the fields so that this overall say uses less space on memory.
Okay.
But with representation C, we don't want that because we are doing custom serialization and deserialization here, and we don't want to have random reordering of fields. We want to stick to the order of the fields, and also it's a C type of representation. Also, we need to keep track of the alignments of this. So whenever you're using your custom serialization and deserialization techniques, you need to make sure the fields are aligned properly. There are no paddings and stuff. Yeah, that's about it. We also need to know the length prior before. So that is why we have some const here. Yep, I'll discuss these takes in account, data. So here, yeah, close this. Okay. So here we try to destructure the accounts, add the pair, state, rent, program. So pair is the one that is the account which is paying for this transaction. Also, he's a kind of authority which is creating this account on chain. The pair needs to be the signer. We need to make sure uh, he's the one responsible for the state, right? Also, we need to, whenever we are creating accounts on Solana, you need to know that the accounts are always empty before creating, right? Because you don't want to initialize them twice. So few checks here. And what is rent? So rent is nothing but a state. We call it a sysvar, which is called system variables. On Solana, we have some system variables like clock, rent,
Mm-hmm.
epoch, and a few other states. So those things are crucial for the operations because whenever you want to calculate the rent, so rent is nothing but the amount of lamports you want to pay for the state, so that can be maintained on chain, right? We have all these things here. So talking about another optimization here, we have a zero copy serialization and deserialization using. So what is zero copy is nothing but uh, so let's say you have this account, right? So let's say I try to have this state, and I do this initialize state instruction owner, you know, of default data 32 0, and then I have bump 0. Okay, I have this struct here, right? So if I'm using Borch, so Borch is a library for serialization and deserializing. And if I try to use Borch and try to, do similar to this, from bytes. So the data is in the form of bytes always when it's calling when you're calling an instruction. So you want to deserialize this bytes into a proper structure here. But whenever you're doing that, you're kind of creating a copy on the memory, You can see this is a kind of struct type, but here you can see it's a reference, right? It's a reference. It's not the copy of the struct like this. Instead, it's a reference to the struct because we are using zero copy here. Zero copy is nothing but it uses zero copy abstractions, right? Like this is an abstraction to load the account without creating a copy in the memory. So by doing this, I'm saving a lot of space, and this is fine. This is 32, 64 bytes and 65, but this is just 65 bytes. Yeah, that is fine. But when you have a state like 1 KB or the maximum possible size, right? So those things are gonna cost you a lot because you're creating copies and that is costing you.
Interesting.
So in order to avoid all that, we're gonna use zero copy serialization, deserialization techniques to load accounts. So you guys can read this logic. Have all these set up in this repo. It's also open source. Alex can help you guys to get access to that. So jumping back. Uh, yeah, again, we have few things like checks and all. Who is the owner? Yep. Coming to PDA. So PDA is called program derived address. Uh, so it's kind of an address which is derived by program, and also the program can also the PDA address. It doesn't align with the ED25519 curve. So ED25519 is a digital signature algorithm. It's a kind of it has a curve, points where your key pair lies on the curve. So if it's a PDA account, so where it's not an exactly an ED25519 key pair, you know, it's just an array of bytes similar to the public key struct, but it's just derived by the program. And also the program can create signature for the accounts on behalf of these accounts that you have derived. For example, I'm doing this whole thing here. Like I have create account. I'm trying to create an account on Solana. If you are trying to create an account on Solana, so then this particular account needs to sign the transaction because it needs to prove that it is authentic and it's created by the owner, right? So because it's a PDA account, we don't have it's not a key pair. The program can sign for this operation, and that is how you do it. Right? You call it invoke signed. So invoke signed is nothing but this particular program is signing for this in the runtime, and then the account will be created as a PDA. We also have some seats. So again, PDA accounts are nothing but, as I said, key value pair, right? So you can so this account address is deterministic because we can derive the address like this. You can use some seeds. Let's say you have the seed my state. You have the owner bytes and all these things that can help you derive the address again. It's gonna be deterministic, right? So looking at the processor here, again, you are using a zero copy deserialization here, trying to load and get the mutable bytes. Then we're gonna assign data, the owner, state, data, update count. So all these things we're gonna be assigning to this. Yep. Uh, so far, this is how we're gonna optimize Solana programs on chain. Main things to keep in mind is zero copy deserialization and serialization mechanisms, avoiding heap space, just falling back to stack, and only using heap whenever it's critical, and You cannot avoid that. And avoiding, unnecessary memory allocations. Uh, these are some important things I think we need to keep in mind when designing programs using Pinocchio.
Very interesting, bro. Seems like a very useful framework.
Yeah, yeah, definitely. I have a starter for this. If anyone wants to, start writing programs in Pinocchio,
How do we
work on
start?
that. Yeah, how do we start? So, let me share. I'll cover the test and then go to the GitHub and show you guys.
Awesome. So can we collaborate to Pinocchio you? Can we submit some pull requests and everything?
Yeah, yeah, sure. You guys can work on any programs you like. So you can rewrite existing programs on Solana and publish it. Ask the company to give some recognition or something. Yeah, everything is possible, I guess. Okay, for unit, so we have some tests set up here. I'm trying to use Mollusk here. I'm not gonna dive deep into this. Mollusk is a lightweight Solana testing framework. You don't have to run your validator or anything. So it loads on your own memory. It will load the virtual machine, the runtime. Basically, whatever you need to execute the program, it will spawn everything into that. So you can load programs. You can see I'm loading my programs like this. You can call build instructions, right? And then you can call it like this: process and validate instruction. Similar, I have some test setup. Uh, Good looking into that.
Awesome.
Also, the benchmarks we have. So benchmarks, same. I'm using Mollusk for that. It's almost similar to how we build instructions, but here we have a different API, right? Let's try to use these two instructions are benched. You can see the results as well. So latest results, I think, yeah, this is the latest one. So initialize my state is consuming around 3,361 CUs. It's a lot because we are making a CPI call, and CPI calls are expensive, and that is why it's using a lot of CUs. We also have update my state, which is just using 230 CUs. I bet if you guys are writing it in Anchor, it's gonna be 10 times or 50 times expensive
Wow.
because of a lot of macros and copies and stuff.
Wow, bro.
Okay. Yeah, let's go back to my GitHub. Okay, so I have this Solana Pinocchio starter. I also have a native starter. The native starter is a vanilla Rust program starter, template. It's good if if you are transitioning from Anchor. You guys can look at this, and later I would suggest you to look at Pinocchio because this is a kind of intermediate. The starting comes Anchor. Next, the intermediate is the native vanilla Rust, and then you have the advanced. You have Pinocchio. Yep, do check this out.
For those coming,
So
keep
for
you on. Sorry to interrupt you, but for those coming from Ethereum, there's any sort of easy documentation to follow just to compare things, so I can really quickly just grasp and move to Anchor and then to Pinocchio.
Yeah, so if you look at Anchor document, Anchor Solana, yeah, but sure. Yep, Anchor framework. I think this should be your Bible of Solana
Awesome.
programs.
Nice.
Yeah, I've got everything here: installation, dependencies, playground, quick start. You can go to the playground, right? It's very easy to use. I think it's similar to Remix.
Would you recommend, like, do I need to learn Rust, or is better for me to learn Rust practicing Solana? So should I just go and try learning Rust first, or it's better to learn as you go on Solana?
Yeah, I would say Rust is much needed. On Rust, yep, this is it. Go to the Rust language and then get started. I think learn. Yeah, read the book. If you have this Rust book, so just get started with this. I would say you can go tell common collectors, error handling, generic types to write tests, right? Okay, I think we can do till 13. Yeah, till chapter 13. I think we have to cover everything till there. You need to cover data types, functions,
Okay.
enums, structures, functions, pointers, references. Yep. So these things are important. So just get yourself comfortable with Rust. Then I would say you to dive into Solana.
Awesome. Thank you so much, brother.
Okay. So similarly, we have a Pinocchio starter. Uh, the README is there. You guys can clone it. Also, a well comprehensive document has been given. Just look at what each directory has. You know how to build the program. You need to do. I think you can get all these tools set up in Anchor docs. So just need to be make sure you have all the tools, dev tools for Solana, like the build BPF, right? So for building programs, running tests, benchmarks as well. Yep. So yep, I think this is a comprehensive one. A few starters, and if you need some examples, I think I recently wrote a associated token account program on Solana.
Mm-hmm.
Oh yeah, so yeah, this is one. I think it was done 2 days. Yeah, on Sunday. Yeah, it was published on Sunday. I just wrote it. You guys can go to this and see how the program looks. It's a very small one. So this was initially written in Anchor. I guess not Anchor, maybe Vanilla Rust. So I have rewritten this into Pinocchio because we also have a Pinocchio version of token program.
Okay.
So if we look at this, we have P token. Solana is already in talks to swap the deployed program, the SPL program with P token. Also to mention Fibo, so one of the legends who wrote the framework. So this is his GitHub. Also give him a follow. Is the inventor of Pinocchio. A Chad, I would say, is into Solana, and
Nice.
yep, a good account to follow. So yeah, as I was saying, so yeah, Solana in talks with swapping the SPL token program to P token. You can see all the CU measurements here. Just look at this, 100 to 2967. It's like 10, 20 times
Yeah.
reduction,
Yeah.
I would say.
Much more efficient.
If you calculate, yeah, exactly. So if you calculate everything and do an average percentage, you get it 90%, 95% P token is
Wow.
CO efficient, right? That's a huge number. We got, a few calls. We look at it. Initialize account, it's 4,500. It's
That's great.
literally 3 times.
That's great.
Yeah, 20 times. Yeah, a crazy amount of difference we get to see.
Yeah. Wow.
Well, this is going to get deployed soon. Uh, this is great for Solana because uh, many DeFi is totally dependent on this token program,
Mm-hmm.
and it's DeFi invoking a lot of instructions, causing a lot of CUs to spend on. But if you get this deployed, it's gonna scale. 90%. reduction in use.
Wow, that's
TPS is gonna scale. Yeah. So TPS is gonna scale again, I would say linearly, right? So those things are there.
feels a little bit like
Yep, I think.
yeah. Go on.
Yeah. Yeah, I think that's it for the presentation I got.
Do you have a final message you want to leave for people that will hear this in the future?
Yeah, so anyone who's looking to dive into Solana, I think you guys definitely need to look at it. Initially it's gonna be hard learning Rust, understanding the Solana's framework, how Solana works. But it's worth it in the future because there's a lot of opportunities for you guys. Not only learning Rust is gonna pay back because many high performance systems, decentralized systems are built with Rust.
True.
With its you get to learn a lot, and the community is so welcoming you guys, and there's also a lot of job opportunities if you guys are looking. Yep, you guys can start building programs.
Yeah. I'm gonna add a little bit onto that. Very good point, Naga. So what I want to add is we are right now facing a recession. If you look at IT overall, if you look at infra, there's a lot of jobs being lost. People they are losing their jobs. There's not so, especially in the EVM ecosystem, there's not so many jobs available. But on the Solana side, things are going wild. There's a lot of opportunity, a lot of jobs. Actually, if you create a protocol yourself, there's a great chance the Solana Foundation will fund the first investment from the protocol, and you maybe get even a VC. So as our friend is showing right now, jobs.solana.com, a place where you can check for different jobs. And so it's worth, guys, getting to this flight. Maybe Rust would be the language that won't be so dominated by AI, so botted because of the specifics. So yeah, please get into it.